Okay, welcome everybody. I wanted to share some information. So this talk started with something I was doing at work, right? And I thought, hey, there's no one out there talking about Prometheus. And there's no one talking about metrics. So as it turned out, and I started working on this talk, there's a great guy doing a talk on Prometheus, by the way. And it turned out I had so much information to share just on metrics. How do we do metrics, right? So if you're expecting a deep in-dive look into Prometheus, I'm sorry, this is not it. I will give you enough information to get started with it and to work out of it. But we're going to talk a lot more about metrics. So just to set those expectations for you before we start. Because the first question I need to ask you is how do you do metrics? How do you think about metrics? How do you approach metrics? Now, since this is a talk that involves Prometheus, there's the obvious joke I need to make is, do you actually do metrics like the scientists from the movie Prometheus? Right? Do you just randomly walk up to this random alien and poke it? Is that what you do to your application? Like, what should I measure? Let's just poke the application and see what happens. I surely hope that's not how you're doing it. So let me share you a few ideas, and maybe we can prevent all of these great scientists out there doing this. So, obvious introduction part first. My name is Rafael, if you haven't seen me before. And I work at Usability. Now, usually I don't spend too much time speaking of where I work and all that. We are hiring, which is always good to know. But this time it's really important. Usability is essentially a voice of customer solution. So we track feedback, right? We track feedback for our customers so that you can know what your users think about your website, about your digital experience, what you're doing. So it's essentially a voice of customer solution. Now, why am I telling you about Usability? Thing is, the root of this talk lies within the latest project that I've been working on at Usability. Now, Usability, if you've ever seen it, is a large product, has been around for a few years. And, legacy has grown, as legacy does. And we got to a point where we realized the way it had been built just wasn't good enough. And we're talking about receiving loads and loads of feedback. So we created a new project, which we call the feedback pipeline, in this case, the unified feedback pipeline. Because we still have feedback coming from various different channels being treated like feedback coming from various different places. So the feedback you get from your mobile application or from your website or from your email, these were all different concepts within the original idea of Usability. Now, in the market we're in, it no longer makes sense because you want to look at that data across all of your channels. So thus, the pipeline was born. Now, I've been working with this, and if you want to hear more about the actual pipeline and how we did it, Luis has a talk tomorrow, Luis Cabucci. So check that out. It shares a lot of the information. Because this is a really complex project. We're using things like Kafka, autonomous microservices. If you went to Matthias's workshop yesterday, you probably heard about that. And all these concepts have one very important part of it, which is monitoring. Right? If you can't tell that your things are going well, you're probably going to have trouble, especially if you're working with microservices, right? Instead of having one problem, now you have distributed problems. So if you can't keep track of those, it gets really challenging. So this pipeline, essentially what it does is it's responsible for receiving all the feedback that we get from our users, from the users of our customers, process it, consolidate it, make sure it's integral and we have all the information we need, and then stick it up on the dashboard so the user can draw conclusions from it. So we do all the analysis and everything that you need to understand what is going on with your website. Now, I'm sorry if this sounds like a pitch. It's not. It's a technical talk, right? And at the core of this and understanding how to build a pipeline like this lies metrics, because metrics are essentially an insight into the current state of your application, especially when you're building complex pieces of code where it flows and the data goes back and forth. Understanding the state of your application is really important. What's going on? What am I processing? Where are things stopping? Are things dropping off the pipeline somewhere? Turns out losing people's feedback is not a good idea. So we want to make sure we're not doing that. Right? And metrics can help you do that because metrics can tell you if your service is healthy. Especially with microservices, I am going to deploy all of my services, that starts becoming a little more complex. You're not deploying your monolithic application, which is a 2-3 hour process, and that's already wrong. You're now deploying a whole bunch of these little services, and you want to make sure they're all healthy, right? If you're doing things like canary deploys, where you roll them out, check something like an error rate to make sure that you can then move all of your traffic over to the new service. So metrics are what's going to give you that confidence to be able to do it. Metrics will essentially tell you what's wrong with your application. You know, maybe your queue is being backed up, or maybe data is just not reaching your logs, or maybe feedback is just dropping completely off the pipeline. Metrics can also tell you what's right. Hey, look, we are getting all of these feedbacks. They're coming from all these customers, from all these different places, and that's great. And finally, which is actually quite incredible, metrics can probably tell you what will soon be wrong. Right? The art of preventing errors before your users start screaming into your ears. So with metrics, you can figure out, hey, this queue is starting to reach a limit. We need to start scaling before we get there. Or we need to understand what's going on with our databases. Maybe we need to start looking into sharding the data, normalizing it, different styles of handling all of these loads. So metrics can do that to you, right? They can do that for you. And the metrics can finally also tell you where to start looking at solving problems. Right? They tell you, like, hey, these are the decisions you're going to have to make in your project. Now, okay, where does this come from? So there's a concept called site reliability engineering. There's a great book by O'Reilly written by the people at Google. And this is essentially Google's approach to maintaining their services online and making sure everything is working smoothly. Now, it's a great book. It's about this thick. Lots of different concepts, so I'm obviously not going to share everything. But there's one part of it which I was responsible for in our pipeline project, which really called out to me, which is a part that talks a lot about metrics. And it defines three interesting concepts. The concept of SRIs, service level indicators, SLOs, service level objectives, and SLAs, service level agreements, which we probably have all heard. How many of you have heard of SLIs and SLOs before? Cool. So this is a really interesting concept, right? The idea of SLIs is essentially they are quantitative things that you can watch, right? So these are essentially your metrics. They are a measure of some aspect of your application that you can look at and say, yeah, okay, cool, I got this. So for example, your response time was 150 milliseconds, right? That's a palpable number that you can now track and observe. Now, we can have plenty of these, but without understanding what 150 milliseconds mean, it's really hard to do anything with these numbers. That's where objectives come in, because objectives will give you a target range or a value for that thing. So 150 milliseconds is a number. If you know that that number should be below 200, then you understand, oh yeah, 150 milliseconds is good. 300 milliseconds would be bad, right? So you're attaching value and information to your SLI. So things like this, hey, response time needs to be below 200 milliseconds. That's a goal that you're trying to achieve your application. This guides how your user experience is going to be, for example. And turns out SLOs actually have another very interesting aspect because they really help you drive architectural decisions. If you know that you need to achieve 250 milliseconds, or in this case, 150 milliseconds, once you reach that goal, you know you can stop investing time in optimizing that stack and go somewhere else. So a practical example from the pipeline, we set our SLO to 150 milliseconds, and I'll tell you how we got to that value in a little bit. But as soon as we rolled out our initial bare-bone frameworks, when we ditched our Symfony stack, replaced it with a Zend expressive layer with a small layer called Chimera, which Louise is going to talk about tomorrow, which was essentially a micro-framework architecture focused on CQRS. As soon as we rolled that out, we were achieving on a 95th percentile the PHP processing time of about 5 milliseconds. I mean, we know how to run PHP applications. We know that from 5 milliseconds of PHP to all the Nginx and network overhead, we were still way below 150 milliseconds. So we decided, you know what? We don't need to invest any more time in slimming up this stack. We can actually go look into our domain, go see what new features or what we actually need to do with the rest of the pipeline. Instead of spending time optimizing, when someone comes up to you and says, hey, you know what? You need a cache layer right here. This can tell you, do I? Do I really need a cache layer? Is it going to improve my SLO? Is my database server going to fall over if I don't put a cache layer? Right? So these questions are questions that we sometimes rely on common sense to make these decisions. And that's not really good. Right? If I tell you, do you need a cache layer between your database? Are you going to come and say, yeah, of course, because, database. That's common sense. I'm like, is it really? Do you know what the database is doing? Do you know the environment you're in? Maybe you don't need a cache layer, right? So driving these decisions is something that metrics can really help with. Once you have these SLOs, they're great, but without power comes great consequence, something. You need agreements, right? So service level agreements put a consequence to your objectives, right? This is where it starts leaving development land and it starts going into business, legal, client conversations. This is where you say, hey, look, I expect 99% of our stuff to be under 150 milliseconds. If they're not, we will pay you back for that amount of time where it wasn't, right? So this is where you attach consequence to those objectives that you're doing. Okay, it's all great if you tell users, yeah, my stuff is all really quick, and then one day it isn't, then there's no consequence. Does it really matter to the client if it was quick or not, right? So SLAs are a bit more of a legal thing. I'll cover them briefly, but these three concepts rule the base of building new applications. I thought they really had something interesting to share with this. So to start off, well, we need to measure, right? If you want to do metrics, the first thing you need to do is measure. So I was reading once a great article by Etsy.com. And in that article, essentially, they shared their philosophy for doing metrics, which boils down to, if it moves, they track it. You know, let that sink in for a moment, because that's a lot of information you're tracking there, right? If we look in general at metrics, I tend to divide them mostly in two objectives for those metrics. First one being telemetry, where you want to know exactly what's going on now. You want that real-time feed of what is happening on my server, how is my application doing. And the other part being more statistical, where you're looking at, you know, what has been happening. You're looking for patterns over time. You're looking for what happened at that one moment in time when we know we had an issue. Right? Those are two different ways of approaching metrics. So to go deeper into that, I mean, telemetry, we all know. Like, how many of you are Formula One fans? Okay, so a couple of people know what I'm saying. That's good. But if you look at telemetry, right, this is essentially the car, the Formula One car, reports back to the pit stop, to the garage, all of these detailed informations about every piece of the system, right? How the power in the motor is being divided, how each wheel is responding, what's the traction on each wheel. So these are going all the way back straight to the garage, and there's engineers sitting there and looking at all this data and making sense of it. They understand, oh, if this tire is showing less grip on this curve, it means they need to turn it a little bit more, you know, to the left or to the right, or take that corner a little bit faster or slower. So they can actually go back to the driver and say, hey, just adjust this little thing, and you're going to get so much more output from the car, so much more speed, so much response. Now, that is extremely powerful if you think about it. It's so powerful that Formula One kind of forbade them to do this, right? It's like, it's an unfair advantage if you have someone saying, okay, now turn your slightly more to the left or go slightly slower here, because it gives them an unfair advantage over other people. Same thing about your application, right? This is a really big advantage for you because you understand, oh, what does it mean? What's happening on my website right now? It's like, I know I have 50 users active right now, but you know, how is every little bit of my application reacting to that? How is it actually moving forward? How's, you know, are my servers up? Am I dealing with this? Can I optimize something? Oh, maybe if I do add a cache layer here, I'm going to get a bunch more throughput, and that's really good for me. So that telemetry really tells you, gives you a lot of the information of what's going on right now. Whereas statistical data, it's more like you know, trying to figure out, okay, who won the championship last year, or who won the championship a couple of years ago. And then you can go back, and you can actually go back in history and look for all this information. And if you go back far enough, you might actually find a Brazilian winner. I really miss Ayrton Senna. We haven't won anything in a long time, so it's sad. But that statistical data is really powerful because you can find patterns, right? You can go back in time and figure out, okay, you know, every time this database reacts like this, or we have this amount of users, this other thing happens which we need to worry about. So looking for those patterns, understanding the patterns of your users gives you a lot of insight into your users and into your applications. So it's really important to also have that statistical data. If I bring you back to the pipeline project, for us, telemetry was all about the response time, right? We have, in that pipeline, we have a public endpoint, which is where we receive all this feedback coming from our users. And to us, that endpoint really needs to be quick, right? It really needs to respond to the user as quick as possible. So that's our telemetry. We keep track of of that point to make sure what's going on there. Whereas statistical data, we look a lot at, for example, how many feedback items came in, how much is the system being used, where do we have peaks of usage, which means maybe a client rolled out a new application or a new campaign, which is targeting users. So all of a sudden we get millions of feedback items coming in over a period of 5 minutes. Can we react to that? Do we need to react to it? Is the application auto-scaling properly? What's going on there, right? So these statistical data, we can go back and prove that these things are working, but they can also give you a little bit of that per moment insight, right? So back to what Etsy said, right? If it moves, we track it. Now that's a lot of stuff, right? Think about it. You can track request latency, you can track availability, error rate, resource usage, but it doesn't stop there. You can also track how your PHP is doing. You can check, disk space. You can check your CPU loads, the incoming data that's coming in, how much stuff, how much throughput you have in your system. And if that's not enough, in true who watches the watchers philosophy, you can actually watch your monitoring system to make sure it's still getting all the metrics that you're sending to it. That's a lot of metrics. It's a lot of information going out there. And then turns out, and I mean, we use the bill, I kind of know this, is if you throw all the information at users, they're going to go, great. What does it mean? What is this, right? It's really hard if you just get all this information to actually make something out of it. So, okay, we have all these metrics. What do we do now, right? I told you to measure everything. If it tracks, move it. Or if it moves, track it. There you go. Metrics are really hard, I tell you. But that means you have all this information. What do you do with it, right? And where does SLIs and SLOs come into it? So from all these metrics, you need to figure out the ones that are really important to you. And this is where I separate metrics from service level indicators. Because service level indicators are a subset of all your metrics, right? You can't keep track of all these things. You need to keep track of a couple of them. You need to keep track of the important things. So you need to pick a few SLIs and not all of them. So how do you do that? How do you pick good SLIs, right? Because that's the name of the game, right? Otherwise you're just measuring everything and you're overloaded. The thing is, you need to understand one thing before you pick them, is that SLIs really depend on who is looking at this. Different information has different value to different people in your company. Maybe business has one interest on the amount of incoming feedback. On the other hand, the developers want to know, how much response time we're giving these requests. And maybe the infrastructure people, they just want to know if the CPUs are, at a good level, or if we don't have memory overload or that kind of stuff. So depending on who's looking at this information, the SLIs may actually be completely different. So it's really important for you to understand what your audience is and what you're planning for. So your metrics might be different from another team's metrics on the same system. And that means you also need to understand the nature of your system, right? We have different systems out there. We have APIs. We have systems that have UIs that are accessible directly via the browser. We've got storage systems. We've got big data systems. There's all these different things there that each have a different nature. Take, for example, a user-facing system. Things like availability, throughput, or latency. Those are really important. Like, is my site actually up? Can people reach it? How many people can I withstand all of these people sending me feedback at the same time? What's my throughput there? And latency, am I taking 5 minutes to respond to these people? Maybe that's not good. Maybe I need to respond faster. So that's really important when you're talking about a user-facing system, be it an API or be it a browser UI. You want that reaction with the user to be good. But if you take, for example, a storage system, data durability might be a lot more important than your throughput. I mean, it turns out that if you send stuff to the database and it doesn't store it, it's not really quite a good database now, is it? So you want to make sure that you're actually storing data, durability of your data. You're not losing it to buffer overflows or just piping them out of your memory. You want to make sure your durability is good. And then we have big data systems where some of the little things don't matter, but you need to have the ability to handle throughput, right? These are the water hoses of the internet, right? Just continuous stream of data that you need to be able to put up with. And then your throughput and the ability for you to process all that information becomes a lot more important than all these other details. Right? So each system has its nature that you really need to think about. Okay, that sounds great, Rafael. I have no idea what you're saying, but bring that back. So again, I'm going to use the pipeline as an example. We looked at it, and essentially the pipeline has two factors to it, right? A user-facing application, so the API where we receive and send data, and a big data factor to it, which is where we actually process all that data and get it to the user's dashboards. So we looked at what we needed there from a development team perspective and came up with a few SLIs. So a few examples there. We looked at the response time of the receiving endpoint. I mean, it's very important for us that that response is as quick as possible so that the user feels that his feedback or her feedback has been received, right? The turnaround time, like how long does it take for a feedback item to come in and actually be shown to our customers? Like, hey, someone enjoyed what you did on the website, right? The individual processing time per step, because that affects the turnaround time. We need to understand like which one of these steps is taking longer. Some of these steps have external data processors to do geolocation tagging and information like that. Is one of these maybe taking too long? Maybe their API is not responding well. What do I do? And then finally, understanding the data that's coming in is important to us because we know which channels are coming in, which means they're going to trigger different steps of the pipeline that are more important, more heavy or not. Right? So you need to understand all of these things. So from our perspective as a development team, these were the things that we were really paying close attention to. Now, if you look at our system, there's a lot more metrics there, which to other teams are different. So for example, if we take the infrastructure team, they care about how their node servers are doing, how our metrics are doing with the CPU and the memory. We're running all this on Kafka, so if Kafka starts spitting bits out, we kind of want to know that because you don't want to lose feedback again. The size of the cluster, are we now running 17 machines where we should have been running only one? What's going on? Can we optimize that? So these are things that the infra team cares a lot more than us in the development of the application. But they're also very valid. Because at the end of it, you need to ask yourself, what is it that your user is doing? How are these metrics telling me about the experience that my user is having? At the end of the day, we're all talking about delivering user value. So once you have a list of these SLIs, you need to start picking the targets. What do you want to achieve? Now, spoiler alert, this is not going to be just randomly picking a number, just to make sure you don't think that. But what is picking values? It's simple, right? You're picking either something that needs to be higher or lower than that value, or a range. It needs to be between this and that. Depends on which metric you're using. You're going to pick one of these constructs. First step to picking a good objective, and we all tend to do this, especially if you're not in a greenfield project, is don't fall into the fallacy of picking your targets based on the current, your current system. Like we look, hey, we're replacing all of these things with this new thing, so it should work the same way. It's a valid conclusion, but are you actually replacing one for one? Maybe your new system is a completely different nature. Like we're now delivering a system that's way more focused on big data and partial processing than the previous one was. So we need to understand that nature again. So don't just base it off of what we had before, like, oh, we need to keep that. Understand what that change means to the user. If my response time is larger, where does it affect the user? What happens to that experience? So really go through these concepts. What is the user trying to do with my system? Don't just base on what you had. Now, we did this for the pipeline, and as is a challenge in every company, how do we communicate developers and business people, right? If we start talking too technical, they will doze. If they start talking too much about the user, we will doze. So we need to find that common ground. So how did we approach figuring out our SLOs and having that conversation with the company? So what we tried to do is we tried to come up with a question that explains value delivered to the user. So in this case, we focused it around the experience of the user. So how long does it take between a user clicking the submit button and knowing and getting a confirmation that that feedback is now safely in our hands? Right? This is the value the user wants. The user wants to go through your website, click there and say, I hate your button, click. And you want that, he wants to get that feeling that, hey, we have received your feedback, don't worry, someone is on it. So that response needs to be probably good. But what is good, right? What does that mean? What is the experience the user wants? I mean, if you ask developers, we always want to overachieve, so we're going to say, it needs to be great. It's going to be amazing. But what does it mean? So we went out to the different teams in our company. We talked to the support team, to developers, to product owners, and we got various responses. Some people say, hey, it needs to be immediate. Some people said, we sell it as real time. Guess which department that was, right? We talked to other people who said, yeah, no, it's going to take long because we need to handle all these other things. There's HTML in the middle. It's going to be really slow. Guess what that was? Right? Previous developers. Oh, it's great. Right? It's engineering. We always want to make things more complicated than they sound. And then we asked some people, and they seem to say, I don't know, it just needs to work. We're like, okay, cool. It needs to work. We can work with that. But we took all that information and now you make sense. And like, I'm not kidding, I did get some of these answers, but we also got a lot of valuable answers. Although I make fun of sales here, but understanding how this is being told to our end customers is really important, because if we're setting expectations there and not meeting them in development, that's a big problem for the business. So we talked to them, and essentially what we did is, okay, so they want immediate. We try to figure out what does immediate mean, and it turns out that immediate for human beings, the perception of immediate is between 100 and 200 milliseconds. Turns out the average API endpoint in the internet, that the good ones, is 180 milliseconds. So we, after all of this research, we settled on 150 milliseconds as our SLO for that endpoint. Now, right now we're like completely below that, which is great, but we know that if we ever start reaching here, then this is where we need to start worrying about it again. So in picking SLOs, pick some, don't pick too many. Otherwise you're going to be flooded again. A good SLO will help you make decisions. Like we said, like these are supposed to also drive your architectural decisions. They will help you in an argument with your product owner. Like, do we need to do this? Do we need to do that? I need more time to implement caching because we're not hitting the SLO. I need more time to do something else. Or I need less time because we're good. Right? So these SLOs should help you drive those arguments with business, and should also help you make your architectural decisions. And finally, don't overachieve. Well, not finally, because there's still a lot more, but don't overachieve. Now that sounds counterproductive, right? I mean, we're developers, right? We just got told by Samantha, we love, like, oh, we can do this. We can build a bridge. It's fine, right? We love to overachieve. But why is that bad? What's going on here? So there's a story. It's called the Chubby project. So this Chubby project, I have no idea where the name comes from, is a project within Google that is relied upon by many other systems in Google. Now, the system was very well built and was doing its thing very well. And their SLO of uptime was the 5 nines, right? 99,999. And they were hitting it, and it was great, and they were delivering, and all these systems were relying on it. Like us developers do with S3. It'll never go down, right? We can rely on this. It's great. It's always going to be up. So what happens is all of the systems relying on it didn't have fallbacks. Turns out one day, Chubby went down. Chubby tripped. And all these other systems started blowing up and cascading. It's like the Netflix terror scenario, right? Everything starts cascading over, and all of a sudden everything is down. It's like, oh, really? People didn't think that the system could go down? People got used to this thing being so stable and predictable that they were like, yeah, it's fine. It's going to be there, great. It's like S3. Who has never suffered from an S3 storage outage? And it's like, wait, S3 went down? Oh God! But then the internet's down, right? I don't need to do anything, right? So it turns out that overachieving is bad. So what they did is, and this is really interesting, they dialed it back a notch. They put their SLO at 4 nines, and then that kind of sent a message to people: hey, the system is not fully reliable, so make sure that if it's out, that you have a fallback, that you have reprocessing or whatever it is you need to do. And then they kept watching it. So every month, if they start reaching 5 nines, they will actually forcibly bring down the system to bring it back to 4 nines, so that people don't start getting into the habit of feeling that it's too reliable. That's genius, like breaking things because you want to break things. It's great. It's like, being paid to do what we actually do. It's amazing. So, I mean, think about this as well, right? Also, think about the message that your SLOs are sending out to your customers and to the people relying on your systems. And finally, adapt and evolve, right? Projects change over time. The nature of projects change over time. Make sure your SLOs are matching what your project is doing over time as well. That brings me back to the legal consequences of this, right? If you're hitting your SLOs, if you're not hitting your SLOs, you need to tell people what to expect from this. So essentially attach objectives to, attach consequences to your objectives. Now, the one thing I can tell you about this, again, this is not going to be too much of a developer thing, but you need to be aware of it. Business is probably going to rely on you to explain to them what some of these things mean. Like, can we attach consequences to these SLOs? So you should be able to tell them that. But this is a place where the night is dark and full of loopholes. So please talk to legal. Don't try and do this yourself. Talk to legal, understand what it means to have these consequences. And then do them. If you don't have to have them, then yeah, great for you. But make sure you're not just doing this for kicks. It can have consequences, and that's not always good. But there's also something else that I can recommend to you, putting in safety margins. Right? So this is like when you put an alarm before your actual alarm so that you start waking up, so that when the alarm goes off, you're like, oh, you need to get up. And then you're not 5 minutes late to the conference. It's good, right? So add those safety margins to your SLOs. Put the SLA slightly above your SLO so you know if you start hitting the edge of your SLA is in danger, but you still have time to react and try and fix that before it actually has consequences, right? Really understand the nature of these two things. Cool. All right, done with theory. Let's talk about practice. All right. So in order to have metrics, in order to have SLOs and have all these great things, we need to collect metrics. If you're not collecting metrics, then it's useless. Now, it turns out there's a great system for that called Prometheus. That's the tool we chose for the pipeline project. It was built by SoundCloud together with Google. It's open source. It's an amazing tool. And it really does a good job. How many of you have been using Prometheus lately? All right. How many of you are looking into it? Cool. So the great thing about Prometheus is it works on a different model. If we think about usual metrics, we have our applications, and they will send metrics to a metric server. How many of you use Influx or StatsD or some other tool for metrics? I'm not counting Google Analytics here. Cool. Right? That means your server needs to scale along with your application, because if you have 50 applications that are scaling and doing beautifully, and you have one metric server, it starts tumbling down because it can't handle all that, right? So it does have a scale challenge to be able to get here. What Prometheus does is Prometheus turns this push model completely on its head and makes a pull model. So the applications will store the current metrics, the state of the metrics at that point locally, let's say APCU, Redis, whatever. It will store this information locally. And Prometheus occasionally comes to your application and says, okay, give me the metrics. So all you need to worry about really is scaling your application. Prometheus is just one instance. Well, it can also scale, obviously. But it turns the pressure the other way. So it makes it a lot easier to get that information and mess around with it. So this also brings an interesting challenge. If you don't configure Prometheus correctly in your application correctly, you can DDoS yourself by getting metrics, so that you stop other DDoSes. So be careful. But understand that you're now hitting your application for metrics. Now there's multiple ways of rolling out. Essentially, it's an endpoint on your application. You can roll it out along with your application. You can have a separate pod in your Kubernetes or a separate container or a separate server that reads that information off of there and gives it to Prometheus. There's multiple ways of doing this, which are all simpler than trying to scale everything around it, right? Again, you can use Redis for this, so it makes things a lot easier. Now, we talked about the types of metrics, we talked about telemetry, and we talked about statistical thing. And it turns out Prometheus is really good at telemetry, right? Prometheus is not geared necessarily for the long-term storage and statistical analysis. So it's a really good tool for telemetry. It's really good at telling you exactly what's going on at your service. Those metrics come back, really quick, and it's able to parse them and give you a very powerful DQL to be able to work with that and have that data. Now, if you want to do more statistical and look over, longer term, you want to go back a year and see what was happening there, Prometheus has rolled out a couple of features that do improve that a lot in Prometheus 2.0, so definitely check that out. But it also has plugins that can help you with that. So it will send all the information it has over to StatsD, over to Influx, which are very focused on that long-term analysis and being able to store that more as a database than just a telemetry system, right? So if you have that need, these can really help you achieve that while still having only one layer to talk to, right? It's complex enough if your application needs to talk to Prometheus and Influx and something else. Better if you have only one tool that your application can talk to, and even better if it's something like the Prometheus model where your application just exposes that data, someone else takes care of making sure it's getting somewhere. Cool. With that, Prometheus has 4 basic types of metrics that we can use. The obvious simple ones in yellow here, and in green the more complex and less often used ones. Counters. Simple, right? Counters are numbers that go up. So if you have the amount of feedback items coming in or the amount of requests that you have handled in a day, these are just numbers that can then roll up and they never roll back down, right? You're never gonna unhave a request during a day. If you do, maybe you should check your server because something else is wrong. Histograms are all about sampling over time and attaching that to a time series. So you can say, for example, response time of your website and track that. Fall it into buckets. So if it's less than 50, if it's more than between 50 and 100, you can track those buckets and then analyze these statistics over time. And what it does in this case, it will share a bunch of these observations, counts, and sums, and the bucket information. Okay, I'm going to butcher this again because I've done it twice. Gauge, gauge, I know. Yeah, turns out gauge is not really a word. Go figure. But these are essentially counters that can go up and down, right? This is very important to tracking things that change over time, but are still an absolute number, and you don't need the history, right? And then finally, summaries, which are essentially histograms, but they calculate on the fly things like the quantiles, right? The 99th percentile of requests and stuff over the last minute or period of time that you give. Now, you can do that with histograms, but you then need to go into systems like Grafana or use a little bit of the Prometheus graphing interface. But with the summary, that's right there. That information just comes out straight with the metric. So you can follow a lot quicker. If you don't want to roll out anything on top of Prometheus, then this will really help that out. Now, okay, how do we do that in PHP? That's what we all want to know. Cool. I have no idea. No, I'm kidding. We use this library, the Jimdo library. It's a great library, very reliable. It's not the most amazing library in the world, but it does the job very well. In my opinion, there's a couple of interfaces there that I think could be implemented to help you mock your stuff a little bit better. But we've had a great relationship with the guy running the library. We've already sent a couple of PRs to add APCU support, for example. So it's a good library. It does everything that we need to do. It supports counters, histograms, and I believe gauge and summary as well. So it does what you need, right? And that's what we want from libraries: simple and straightforward. The way to implement something like this in your code, like I said, since we're dealing now with serving metrics as well. First of all, in your code, you're going to collect metrics, and that's simple. I'm going to show you an example of that. And then you're going to need to expose that endpoint, whether it's in the code itself or another server. That's where Prometheus is going to hit. That endpoint needs to read from the local storage and expose the metrics in the text format that Prometheus uses. All right. That sounds very loose, so I'll show you some code. And there's code. Great. No, sorry. Let's go bit by bit what's going on here, right? The first thing that you need to do, and you can put this in your dependency injection container, is you want to start off a adapter. This is where you're going to store the information. In this case, I'm using APC, which supports APC and APCU, but you can use Redis, you can use anything you want. Actually, there's a real catch to using APC. It means that you need to serve the endpoint on the same server that you're running everything else, because APC is really focused on that process, right? So if you try and measure from the CLI and expose data on the HTTP endpoint, it's not going to be there, which is very confusing, but that's how APC works. So something like Redis is a lot more reliable for these things. Cool, so once you do that, you can start one of the metrics. So I'm going to focus here on the histogram and a counter. And what you're going to do is, first thing you're going to give it is the adapter, where it's going to store the information. The second thing you're going to give it is the namespace of your application, because Prometheus is going to gather a lot of metrics. This is just one of them. Then you're going to tell it the name of the metric. And it's really important for histograms for you to attach, and this is how they recommend it, the unit of measure at the end, so milliseconds in this case, so that you know what you're looking at when you're looking at this outside the system. Then you have a little help text to help whoever is reading this, and then labels and buckets. Now, labels and buckets are interesting. These labels are essentially the extra information you're going to give there, which you can then filter on. So I'm going to tell it what the status was of that request, whether it was a 200 or 401 or 5 or whatever, and the URL, so /metrics, /feedback, /whatever. And then the buckets is where it's going to aggregate that data, and you need to make these buckets probably match around to what your SLO is. Like if my SLO is 150, then I need to understand like the first 50%. Like if it's below 50 milliseconds, I'm fine. If it starts hitting 100 and 100 something, then I need to worry about. So the example will make this easier. If I go here, then I can observe that metric. I'm going to give it the response time, so let's say 15 seconds. And you calculate that. If you want to calculate that within PHP, you're going to do something like count at the beginning, count at the end. You're going to get the PHP response time. Ideally, do this on Nginx if you want to do actual response time. But if you're doing timing metrics, this works. And then you're going to give it the labels. Now, that value of 15, you can remember here we had 0, 10, 50. That value of 15 means it's over 0, it's over 10, but it's below 50 and below 100. So those two buckets are going to get incremented. And you're going to say, yeah, well, I had some requests that were over 50 and some requests that were over 100, but nothing that was below 10, for example. Pretty much same thing with counters. You're going to pass it the adapter, the namespace, the metric again, and the labels. In this case, you don't need to configure any buckets. And then you can count. It's easy, right? You can count by 1. You can count by 5, whatever you want. So that's doing this. I'm going to give you a bit more of a demo on this. Still got 3 minutes to go. Right, the metrics endpoint. Again, instantiate an adapter, then you just need to serve rendered text. So they have an internal renderer in the library. Instantiate that, tell it where to go collect the data, and it's going to output that data as plain text on the internet, which Prometheus can then read. What that data looks like is this, right? So it's essentially just a big dump of text. You can see here the help text that we talked about, the type of the metric, and the counting. So this is a simple counter. We can see here that it's counting 6, which is what we told it, with the labels of a status that was 200 and a URL that was /URL. And if we look down here on the buckets, you can see that the 50, the 100, and the above infinite, those are all counted as 1 because we had a response time of 15, right? So these are all the buckets where 15 goes into. It's not, it's less than or equals the value of there, right? And that's how Prometheus will then give you a very nice DQL to be able to work with this. Now, as I always like to say, demos always fail. That's what I said yesterday. Yet today I'm going to try and give you a demo, because I don't learn from what I say. So if I can switch over. Oh, that's great, but that's not what I want to show you. There, that's what I want to show you. Right, and this is where you plan for demos because you can't read anything. So there's a repo which is on the slides where this whole thing is running. It's just a Docker setup where you have a Prometheus machine and a PHP server that hits metrics on it just for the sake of having metrics. And I'll share the whole thing later. What they'll give you is it'll give you this, which is a Prometheus server running with all the information that it does. So if you check here, you can look at the configuration settings, the targets, and the targets is where it's going to go get that data. So you can see here that I have 2 targets. One target being the application that I've set up. So this is the PHP application here running on port 8180 with the metrics endpoint. So this is where Prometheus is going to go, okay, give me your metrics, right? And then you can also see that it's tracking 1990, which means that Prometheus is actually using Prometheus to track itself. Right, so you can get stats of how Prometheus is running, machine consumption, all that stuff. It does it on its own, right? So it does itself. It's really nice. If we look here, we have a couple of examples of what you can do with it, right? And if we hit the metrics endpoint here, and I'll refresh this because you can tell it's live, and it's generating beautiful random numbers. And they're not changing much, but that's fine. But you can see here that it's tracking all of these different URLs, all of these different statuses, and having the counter for each of those, and the response time. So this is exactly what you saw there, but with a random number generator feeding those counters and those request times, and changing the URLs, just so you see. So now, this is all the information that Prometheus is gathering. What I can do with this information now is I can actually, map it out. So if I go here and I open up a counter, we can see here, if I reduce this a little bit, so we can, there we go. This is essentially taking all of those counters, considering all the filters, so all of the statuses, all of the HTTP, all of the statuses and all the URLs, and just showing me that the counter is just going up, which is great, but that's probably not as productive, because we can also then look at this by status. So if I click here, there we go. Now you can see those statuses by each of these different layers. So here you can see status by 500, 401, and 200. So we can see that we have way more 200 than we have the 500 401s, but you could see those counters incrementing. Now this is all very basic, and the graphing tool that already comes with Prometheus is simple. It can give you one of these graphs, and you can come in here and you can stack it, and then you get nice little colors. Ooh, colors. See? Beautiful. It's not really good at picking colors, though. But this is a simple thing. But if you hook this up to other systems like Grafana, you can really do complex things. So within this query language, and I invite you to explore the documentation a lot more on this, or watch Michael Heap, who's in the next room. He has a great Prometheus talk where he goes over all the details of how to configure Prometheus, how to tweak that configuration, and get all that working. And he covers a lot of the DQL. But with this, you can do things like the sum, you can do the percentiles, you can really combine the rates and really get a feel for what's going on in the server. And I'm going to show you that by coming back to here, if I can find here, and do this. Oh my God, it works. Right, so check that repo. I'll share the slides after the talk, and you can find all that code there, and you can run it yourself, and you can play around with the queries. But the thing is, you can't do much if you can't see those metrics, right? What does it mean if I have numbers? So if you hook this up to something like Grafana, and I can show you an example of what we have, right? This is our response time dashboard. So we can see here we have an error rate, which is essentially tracking how many 500s we have within the pool of our calls. We have an RPM here, so it's using the count of requests that we give it to be able to tell how many requests per second are we having on each of these URLs here, and with which status responses. So like we know we have a very high hit ratio on the metrics endpoint as well, and then the feedback items, and they're all kind of returning 200s. And then with the response time here, we calculate actually not just the 95th percentile, but the 99th and the 999th percentile, right? So how do you look at this data in different perspectives? And we can see here that we're still pretty good in terms of hitting those 150 millisecond things. We're still mostly under 15 milliseconds in the 999th percentile, which is pretty nice. This is all pre-production environment. The pipeline is not yet live, so this is all simulated production stress that we're passing through it. But this gives you a lot of information of what's going on with that system. We also use the counters a lot, like we said, the nature of feedback items. So this is the entrails of usability here. Shh, don't tell anyone. But this is still our pre-production environment, and we can now tell with those counters which channels are getting more data. So when we say things like web active and web passive, we're talking about campaigns or just passive feedback buttons or application feedback or email feedback, right? So those are the different channels we're measuring here. And we know which services are bigger and smaller, which means they trigger different steps. So you can see here, most of our feedback still comes from the web. Application is still a small part of that. And we get all of these comparisons between the various projects. Right, cool. So to leave you off, metrics without accountability are just numbers. So make sure you understand what those metrics means to you, what your SLOs means to you and what you can do about them. Understand how you influence these things on a day-to-day basis. So if you see one of your objectives, one of your SLOs being threatened, act on it, do something about it. But make sure first that you're measuring all these things, because if you don't have the data, you can't do much. With that, thank you.